In this video, we're diving into the common mistakes to avoid when working with MongoDB databases. Whether you're just starting out or have some experience, understanding these pitfalls can significantly improve your database design, query performance, and overall application efficiency. Let's get started by knowing about the common MongoDB pitfalls, including schema design mistakes and inefficient queries. One of the most common pitfalls in MongoDB is related to schema design. In this section, we will explore the mistakes related to schema design. One of the mistakes is over-normalization. A common mistake is applying traditional SQL normalization patterns to MongoDB, missing the power of embedded documents and arrays. On the left, we have the over-normalized example. We are having multiple collections like users, addresses, orders, products, and order items. On the right side, we have the MongoDB way. We have only one collection, that is orders. Inside orders, we have user, which contains name and email, address, which contains street and city, and items, which contains name, price, and quantity. Another very important aspect of MongoDB is indexing. Let's explore some indexing pitfalls that developers generally make. One common indexing pitfall is forgetting to create proper indexes, leading to slow queries that scan entire collections. Creating proper indexes can drastically improve query performance. Some of the index creation examples are on the screen. To create index on single field, use the command db_users.createIndex and pass the field name in 1. To create a compound index, use the command db.orders.createIndex and pass the field names with 1 or -1, 1 for ascending and -1 for descending. For text search index, use the command db.products.createIndex and pass the key value pair, $***, and the value text. Apart from schema design and indexing, query optimization is also very crucial in MongoDB. Let's explore some query optimization techniques and mistakes. One of the major mistakes is using inefficient queries. Inefficient queries includes using $regex without anchoring, not limiting results, or retrieving unnecessary fields. The first example shows inefficient query. Here we are finding from the user's collection where name contains John without limit, and it will fetch all the fields. In the optimized example, the regex is anchored, and projection is used to fetch only name and email, and the limit is 10. Another important concept of MongoDB is aggregation pipeline. Let's explore some aggregation pipeline-related mistakes. One of the major mistakes in aggregation pipeline is using wrong stage order. The match and sort stages should be used before group or lookup stages. In the wrong order example, the group and lookup stages are used before match and sort. On the other hand, in the optimized order example, match and sort stages are used before group and lookup. Let's summarize the key takeaways from this video. First, embrace embedding. Use embedded documents and arrays instead of over-normalizing your schema. Second, index everything. Create proper indexes for all your query patterns to avoid collection scans. Third, optimize queries. Use projections, limits, and anchored regex for better performance. And fourth, use correct pipeline order. Filter and sort early in aggregation pipelines to reduce processing load. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.